In this video, I will show you guys how to write a possible equation for a polynomial function given roots of the functions already. So based on this problem, what we know is we have roots at x equals 1 plus I, x equals square root 3, and a double root as x equals negative 4. The tricky part about this is whenever you have imaginary solutions, even they just give you one, which is a positive one, that means you also have the negative one as the conjugating pair of it. So when we set it up, even you're not given the negative part, but you still have to put it as one of the root of this polynomial function. Okay, and same concept with square root, because we know whenever we take square root, we know for sure that we have positive and negative values. So if you have square root 3 as a root, so that means you also have x equals negative square root 3 as another root of this polynomial function. Alright, so let's start on it. So first step, I will rewrite them and I try to list all the roots that I can think of for this polynomial function based on the given roots. So from here, this one, I know x equals 1 plus I, but I also know the one I can think of is 1 minus I, because they are conjugating pair, and as long as you have positive, you will have the negative one. Okay, and then from x equals square root 3, then even I'm not given that, but I also figured out there also another one as x equals negative square root 3. And the next one, I have double root as x equals negative 4. So I have x equals negative 4. And how we deal with double roots, we will get it in the next step. So now when I list all the possible roots of this polynomial function already, what I do is I try to work backward on each of them, so that I can bring everything to one side and the other side just equal to 0. So now I have x minus 1 minus I equals 0. I have x minus 1 plus I equals 0. I have x minus square root 3 equals 0. I have x plus square root 3 equals 0. And I have x plus 4 equals 0. But I'm not done yet, because the double root right here telling me that I should have square right here. Alright. So then the next step, I will have, so I call my polynomial function as a p of x. So now I have all the roots already in the factor form. I'll put all of them together. So what I have right now is I have p of x equals to x minus 1 minus I times x minus 1 plus I times x minus square root 3 times x plus square root 3 and times x plus 4 square. Okay. However, we try to write a possible equation. Therefore, don't forget to put an a in front as the coefficient, because you don't know whether it's a 2, it's a 3, it's a negative number. Any number can be a. Okay. If you don't put an a, then that means it's a 1. But we're not sure whether we have a 1 or we can have any number instead of just 1. Alright, and the next part, seems like we done with this problem. However, the sentence right here is say in factor form. Yes, we did put them in factor form already, but it has to be with integer coefficients. Okay, so then that means we're not done yet, because the only factor form in integer coefficient is x plus 4 everything squared. For x minus 1 minus I, x minus 1 plus I, they are imaginary number. So now we have to do something to make sure we have the integer coefficients for those parentheses. Same as x minus square root 3, x plus square root 3. So what we can do is we will apply the difference of squares. So if we multiply these two together, and you can work on them on the side too. So maybe I try to work on them on the side so it will be less messy. So on the side, if you have x minus 1 minus I times x minus 1 plus I, what we can do is we can treat this one right here as A, and this one right here as B. So now that means we have A minus B times A plus B, and it's give you A squared minus B squared. So if we using that formula, we will have x minus 1 squared minus I squared. And if you remember I squared is negative 1, then we can do the next step. So from here, bring it down here, x minus 1 squared, if you multiply them, you should get x squared minus 2x plus 1. And then now I have minus negative 1, because I squared becomes negative 1. And then I have x squared minus 2x plus 1 plus 1. And my final answer will be x squared minus 2x plus 2. Okay, and I bring it back here. So I have x squared minus 2x plus 2. Alright, and then next, I'll do the same thing, apply the same method right here. So then I do the same thing. I have x minus square root 3, and then x plus square root 3. I have A minus B times A plus B, and it's also give me A squared minus B squared. So then I have x squared minus square root 3 squared, and it's give me x squared minus 3. So back here I put in x squared minus 3. Multiply between them, and then I have this, just bring it down. So x plus 4 squared, and then A, just bring it down here, and have P of x equals. Right? So then now I will rewrite them one more time as completed answer. So my complete answer will be P of x equals A times x squared minus 2x plus 2, x squared minus 3, and x plus 4 squared. Okay, so then now we have a possible equation for a polynomial function in factor form with integer coefficients. Alright, hopefully you guys can hopefully this video help you guys understand a little bit more, and you can work on this on your own.